How microcontroller with EPROM works. 80C31 microcontroller is a 8051 family micro without internal program memory. 128 bytes of RAM memory, 64 kilobytes external program and data memory address space, 2 16-bit counters, serial communication port. Let's look inside microcontroller. This is silicon chip with bonded wires. 8051 chip from Intel. Internal RAM memory. And external program memory. ROM. 8 kilobytes of code, UV erasable, programmable read-only memory. Let's look inside EPROM. Over 8,000 bytes, 64,000 separate bits. In fisheye perspective. New empty memory contain only ones. Let's write very simple assembly code. This program will set P1.0 of P1 port on low state. And keep it permanently. LJMP is long jump to address of this LJMP instruction. Our code is inside memory. Cables is connected to 5-volt supply and P1.0 pin. What's that? Walking lead diode and resistor? Cathode is connected to negative terminal. And resistor connects lead with positive terminal. Power supply is plugged into the socket and cable into transformer output. Current flow feed this microcontroller board. We have now 0 volts and 5 volts potentials. Blue is a 0 volts ground. Red is a 5 volts one. 5 volts is also on lead diode anode because there is no current flow. Microcontroller didn't set ground on P1.0 pin. But on the chip is happening a lot. It because quartz resonator with capacitors making heartbeat. The heartbeat of 8051 microcontroller. Starting procedures like reset all internal components. Low state on external axis pin means we using external program memory. At the beginning micro set adders latch enable and program store enable in high. P0 and P2 ports are used for address and data transfer. A LE controls address latch device and PSEN controls EPROM memory. P0 is lower address byte and P2 is the higher one. Lower address byte passes through address latch device and comes to EPROM terminals. Higher address bits comes directly to EPROM. When ALE control line goes down to low, address latch device freezing lower address byte. And all 13 address lines sending zeros to EPROM memory. P0 port changing function for read data. When PSEN is set to low state, then EPROM memory activates selected byte. This byte contain data at selected address 00000000. Now this byte is sent to the microcontroller. Because address latch device freeze address sended before, now data from EPROM memory can be transmitted without collision via port P0. And let's look at the random access memory. This RAM is called internal data memory. Program counter register. Data read from EPROM at address 0. This is opcode clear bit. And after that, control lines is set to high again. Address 001 is sent to the memory device. A LE latching a lower address byte. PSEN reading next byte of program. And this byte is destination for clear command. Destination is P1.0. Look at the program counter register, it's 1. And P1.0 register is set to 0, means low state. And finally LED diode is lighting. And again control lines is starting from logical ones. Address latch device freezing address. And PSEN read next command from program memory. Now we have a new assembly opcode. It's long jump LJMP, program counter register equal decimal 2. And all repeated in next round. Read from memory higher address byte, because long jump address is 16 bits value. Program counter increased to decimal 3. And next round of program reading. Now we have a lower address byte, the same address as LJMP command, and program counter is decimal 4. This is infinite loop of long jumping, which cause that LED diode illuminate forever. Let's look at the code again. Clear P1.0 and jump in the same place. This is how microcontroller with EPROM works.